as you all know, I'm Mr. B. You can call me James for today. Our lesson for today is enter. Is this legible in the camera, or do you need it to be legible?
Yeah, I can pick it up.
Okay. Enter the matrix. So that's what our lesson's going to be about today. Get excited. I'll write our learning target up here. Don't have it on any fancy PowerPoint. Just classic writing it down right now.
Classic.
I'll read it out loud in case you can't see. I can represent a system of equations with two or more variables in matrix form. All right, so here's the big idea we're going over today: representing a system of equations in matrix form. And so I'm going to draw a little picture here. This is so when you go home and your parents ask, what did you learn in school today? This is the thing that's going to pop into your mind. It's visual. Here we go. And feel free to draw this. I would actually love it if you would, because this is going to stick in your brain. That's supposed to be a tree. Alright, so what do we got here?
Snow globe.
Snow globe. Okay, so I did practice that for a while to be prepared for this lesson. Feel free to draw a better one in your own notes. So, got a snow globe here. You might wonder, what's the connection? Has anyone here heard that people who speak an Eskimo language have a lot more words for snow in English? Okay, a lot of people have heard that. So I looked it up because I was thinking about it, and it turns out it kind of depends based on how you count words. So, but we're going to assume for today's lesson, yes, they have way more words, and it's way easier to describe snow in that language, in an Eskimo language. So, say you were a poet trying to write a poem, and you want to write about snow. What might you do? You might think, Eskimos are so good at describing snow. I'm going to translate my poem into an Eskimo language. They're the best at describing snow out of anybody. Okay? So we got that? You take it into another language because that language is the best at describing. So that's what you're going to think of when you remember the snow globe later today. Alright, so we've got that, and that's a lot like what we do with systems of equations. We've been studying systems of equations now for a couple weeks, learning how to solve them with, addition, elimination, substitution, graphing, and those work for a lot of things, but when there's a system of equations that has three equations or even more, it gets really hard to use elimination and substitution and stuff. And so a lot of times we have to convert it into this other language, which is matrix form, and that allows us to actually solve the problem. Matrix form is really good at solving huge systems of equations. So that's kind of what we'll be doing in general today. And let's see, so an example could be, you might have x squared plus 2x plus 1 plus 2y equals 10. Then you might have 2x squared plus 3y plus z instead of having to do any substitution or any crazy stuff, what we'll learn how to do is take this and just go 1, 2, 1, 2, 3, 1, X, Y, Z equals 10, 9. We'll do that kind of thing, and this is going to be way easier to solve than trying to manipulate these equations. So that's kind of the idea. We're translating into a different language because this language is way better at dealing with this problem. One of the key words that I want to focus on is this word, represent. It comes up in math all the time. You might have a word problem and you have to represent it in just equations and just numbers and graphs. And you have a fraction, you have to represent it in a different way, or a decimal or anything. Comes up a lot, so I wanted to make sure we're all on the same page with representing things before we hit the lesson. So I thought a cool activity we could do would be, let me take this. You guys are going to be in your table groups. I'll write it big so that people in the back can see. This number right here, number 1, I want you to take, with your table group, work together and think about different ways you could represent the number 1. And I'll give a couple examples to help brain start a little, if it would be helpful. One example you could use for 1, 2 minus 1 represents 1. It's the exact same thing. Another example you could use would be a square that's 1 inches on all sides, or you could use x, if x equals 1. So there's a million different things you could do with this, so take a little time to do this and just kind of practice representing something, this, in different ways.
That's one, I mean, that's one way, right?
One,
right?
And.
Oh, we're going differently with Swedish. Okay.
Okay.
Keep going for a while. Okay. About one orange. One singular orange. That's one, right?
Yeah.
Like that's your unit of counting?
Yeah. It's like how many oranges? One orange. That's fair. That's fair. I don't know how to respect that.
What about Earth?
Just one. Okay. Any number of ones. Or like which one?
So that's why
We don't need to dive into astronomy today. I just read it. I tried to draw Earth and I realized it's really hard.
How goes it?
Circle with a leaf?
Yeah.
What about negative golf?
I like the misspelling.
Let's test you guys. -1 plus 2.
There you go.
We have 1 squared over here. There's 1 teacher.
Okay, there we go.
1 James in his class. Like who's up there?
I love that. We have lots of languages.
Lots of languages? Oh, lots of different ways to say the word 1. Nice. Let's go.
Right. We are brainstorming. We can have fractions. Cool.
Oh yeah, got a lot of different ways. Nice.
I like it.
Good. You guys want to think about maybe some
We could go all
Keep
day.
going.
An idea. Back to 0.
Oh, there we go. I just heard they you have like one slice of a pizza, or just like anything. Like you have one.
But isn't that French?
Well, like the whole pizza. Yes. Then it's like you have but a whole pizza is one, and then they take one. Oh, I have another one. What about 4 divided by 4?
Oh, yeah.
I see what you did there.
How's the brainstorming going?
We're getting good. Creative. Yeah.
Okay, cool. Thinking outside the box.
Yeah, we're using planets and food.
Okay, cool. Great.
And other languages.
Yeah, we had an equation equals 1.
Good, right?
We could do factoring if we wanted. Because we just learned.
We could.
The moon, craters.
One else. We're being artistic again.
Yeah.
I think you just learned to draw.
Alright, so if you can hear me, high five your neighbor. Okay. If I could have you guys come up, maybe we could use a better wall, maybe like that wall. If we could have teams come up and write what you wrote down, or draw, or whatever it is. And then if you have something that's the same as another group, feel free to like cancel it out and not write it, so we don't have overlapping things.
I'm so excited.
Yeah, go for it.
So you all want us to go up?
Yeah, sure. That's great. You can either mop the board or just send one person. I think they should all be on one area. All mixed
Curtis, you want to just
together.
represent? It's kind of hard to be.
Sure.
Well,
Oh yeah, yellow's really hard. Yellow's not good.
If you want to borrow purple, I have that. It's pretty good.
There's one love.
that was Earth. That was the moon. Now she's drawing the moon.
Yeah. One strip. Thank you. We need to talk about
This wedding is almost over.
Yeah, you can share that one with us.
If you have different stuff that you guys talked about.
Some, yeah.
I did that before.
Similar.
Maybe you just only gotta try oranges and that's actually.
No, that's a pretty clear
Got the shade. Yeah, we got some shade.
shiny.
Baseball. I don't know how to infer that. Maybe that
We
means
just read the word 1,000 and it's going to use the baseball. Or dog. Yeah, that's good.
All right, well, let's call it now. If your team had something that was confusing, or does anyone have anything up there that they don't know what it means or what it's talking about, how it represents one?
Which one's the, is that a cupcake with a flame? How does that?
Looks like a pie. A whole pie.
Okay, we got one whole pie.
One whole pie.
All right.
The elephant.
Okay, what's up with the elephant?
It's one.
It's one elephant.
Okay.
One elephant.
Okay, there we go.
That's exactly.
What's the baseball bat with the baseball?
Oh, if you're batting 1,000, that means you get a base hit every time up, which means your probability is 1. It's
Oh.
baseball, they call it batting
There we
1,000.
go.
Okay.
Okay. Oh, okay. All right. So we're running out of time real fast. So thanks for your contributions, everyone. Let's see. Just wanted to summarize really quick. We're talking about representing because a lot of times in math, you're given a problem in kind of one language, and to solve that problem, you could work like crazy trying to solve it in the way it was given to you, or you can translate it into a new language, and that language might be a lot easier to solve the problem. And it's going to come up all over in math and in this lesson. So yeah, I would just encourage you to use that, and hopefully you're all familiar with it. Can I get a thumbs up, thumbs down, depending on how comfortable you feel with this concept? All right, great, thanks.